Welcome to the deep dive. If you're like us, you probably spend some time over the weekend trying to catch up on AI news. In looking at the feed for Sunday, October 19th, 2025, well, often feels like trying to drink from a fire hose, right?
Yeah.
Just a ton of announcements. But when we really dug into the sources this time, it was different. The signal-to-noise ratio was, well, it was flipped. We didn't find a huge volume of scattered stuff. We found, actually, tremendous depth. The updates weren't really about small tweaks or, plashy demos. They pointed to something bigger, something more concrete. The AI industry is fundamentally maturing, and fast. It feels like we're leaving that pure research phase behind. Now the main question seems to be, okay, how do we run this reliably at scale? And, frankly, make money?
That's a perfect way to put it, yeah. The whole industry is kind of shifting its focus. It's moving beyond just speculating about capabilities. Now it's intensely focused on production readiness, like you said, moving from the lab bench to the factory floor, essentially. So our mission for you today is really to distill these key updates into maybe a memorable framework. Let's call it the maturation trifecta, because we're seeing this simultaneous, really high-speed progress in three areas: building foundational reliability, accelerating real-world scientific impact, and formalizing how enterprises actually use this stuff, the industrialization piece.
Okay, the maturation trifecta. I like that. Let's unpack it. We've got sources covering some really cutting-edge research from Meta on controlling these models. And then there's this pretty surprising scientific breakthrough using Google's open models. Plus, we see concrete steps big companies are taking to build, well, scalable AI factories. So let's jump right in, starting with maybe the core technical challenge, right? If the industry is maturing, the first big hurdle is trust, isn't it? We have to get past models that are sometimes amazing, but other times just make things up, hallucinate wildly. So let's start there. With the work aimed at making large language models, especially the multimodal ones, the MLLMs, making them more trustworthy, more precise. Meta AI just published some paired research projects. Seems like a really strategic push towards product readiness.
Yeah, and what's really interesting is how they're tackling two different reliability problems at the same time. It's quite clever. The first paper focuses on something called video temporal grounding, or EDVTG. This is all about perception, finding specific things accurately within a video. Think about it. If you ask an MLLM in a video search engine to find, say, the exact moment the speaker puts on their red jacket, often the model struggles, right? It gets confused by the ambiguity of the context. It might give you back a whole 30-second window instead of the precise, 3-second clip you actually need.
Okay, so how do they fix that ambiguity?
Well, Meta's approach is pretty novel. It basically gives the model permission to refine your request before acting on it. So the MLLM doesn't just blindly pass your query along. First, it enriches it. It adds contextual details, cues it extracts from the video itself that you might not have even thought of. And only then does a specialized decoder use that much more refined, enriched query to pinpoint the exact start and end times. This is huge for things like automated content moderation or detailed forensic video analysis. Anywhere that kind of precision isn't just nice to have, it's absolutely required.
Okay, so that handles the perception side, finding things accurately. But MLMs also generate stuff, text code, and controlling that output is still a major challenge.
Yeah.
How did Meta tackle that, the generation control problem?
Right, and that leads perfectly into their second paper, which is complementary, Reward-guided Decoding. Now this is arguably really crucial for enterprise adoption because it shifts the whole interaction model. We move away from what can feel like prompt and pray, where you type something in and just hope for the best, to something much more dynamic, a prompt and steer model.
Prompt and steer. Walk us through that steering mechanism, because fine-grained inference time control sounds, well, technical. What's it mean for someone actually using it?
Okay, think of it like this. It turns the MLLM from maybe a stubborn automatic transmission into more like a high-precision manual gearbox, a stick shift. In the old automatic method, you hit the gas and just hope the car shifts gears at the right moments. With reward-guided decoding, you're actively using separate, specialized reward models. So maybe you have one model optimized purely for accuracy, for precision, and maybe another one optimized for, say, creative breadth for recall. And these reward models dynamically influence the MLLM's output as it's being generated in real time. So for instance, if you're doing medical image annotation, you can tell the system prioritize high precision above all else. Even if the model has to be a bit less descriptive overall to achieve that accuracy, it's this dynamic moment-by-moment steering that makes the outputs finally feel dependable, contextually appropriate for serious professional uses.
Right, so we're seeing the big labs pushing the cutting edge. But
none of that really matters if the basic foundation is shaky, does it?
Yeah.
Which brings us to the maybe less glamorous but totally critical world of open source plumbing infrastructure.
Exactly. Yeah, even seemingly small infrastructure-focused tools tell you a lot about industrial intent. Like we saw this community effort within Hugging Face around Llama Farm. It's focused on creating reproducible training utilities. And really importantly, configuration hygiene for Llama class models.
Okay, configuration hygiene.
Yeah.
Why isn't that just mundane? Why does that matter?
It matters immensely because without it, trying to compare a llama model trained in Lab A with one trained in Lab B, it's like comparing apples and pears. You just can't. If you can't trust that the training environments were truly comparable, the configurations, the hyperparameters, all of it, then you can't trust the research results, and you certainly can't reliably industrialize that model family. This whole effort is about making sure the entire llama ecosystem operates on consistent, traceable standards, building that trust layer.
And that ties right back into the enterprise focus on reliability, doesn't it? We also saw some deep community notes being shared about managing high-dimensional vector embeddings efficiently, particularly in platforms like Pinecone. But hang on, isn't vector management something only, like the giant tech companies need to worry about? Why should someone listening, maybe with just a mid-sized RG system, care about technical details like total cost of ownership, TCO?
That's a fair question. You should care because that technical detail very quickly turns into a major business cost. As your retrieval augmented generation system, your RU system, scales up, maybe you start running millions of queries a day. The efficiency of how you store and access those vector embeddings, that directly determines whether each query costs you, say, a fraction of a cent or maybe a full cent. And that tiny difference, it adds up incredibly fast. We're talking potentially millions of dollars in annual TCO. So this kind of community intelligence sharing is vital for engineering teams. They need these practical insights to tune their production stacks so they're actually affordable and fast enough when running at scale. It's absolutely core to reliability, both technical and financial. Okay, so we've talked about building that foundation of stability and control. Now let's shift to how these more reliable models are actually delivering measurable outcomes. And here's where it gets, I think, really interesting, showing AI's immediate scientific impact. Google presented just a profound example of how these open source models are driving high-impact science, like right now.
Okay.
What did they show? Well, their open-weight Gemma AI model. It was instrumental in helping scientists identify a potential new cancer therapy pathway. A specialized, fine-tuned version of Gemma actually identified a previously unknown network of genes involved in drug resistance in human cells.
Wow. Okay, that is a landmark achievement, no question.
Yeah.
But does something like that silence the folks who argue that the next big breakthrough still needs those giant trillion-parameter proprietary models? Or is this maybe just an exception?
It doesn't silence them completely, no, but it definitely shifts the goalposts significantly. We hear it all the time, right? That only these massive, closed, proprietary systems can really deliver the big breakthroughs. The Gemma example powerfully validates the idea that smaller, accessible, open-weight models can democratize high-stakes scientific research. It opens the door for academic labs, smaller research groups globally. It suggests you don't necessarily need a multi-billion-dollar budget to explore novel gene networks anymore. What you need is smart tuning on an accessible, reliable foundation.
And that ability to produce repeatable, high-value results, that feeds directly into the second theme you mentioned. Enterprise industrialization. It's not just about having a clever model anymore. Companies need to formalize the whole process of using it effectively. VentureBeat highlighted this emergence of AI enablement and prompt ops as like a new discipline within enterprises.
Exactly. This is a huge signal that AI is really moving out of the research garage and into the day-to-day professional workflow. Prompt ops is about formalizing roles, governance. Things like creating shared prompt libraries, setting standards for testing, ensuring traceability, all the stuff needed to let teams that aren't machine learning experts safely and, crucially, repeatedly ship workflows that use generative AI. It kind of elevates the role of the teacher, the person who really understands how to communicate effectively with the model right alongside the engineer who builds the underlying infrastructure. Without this kind of structure, every AI project just remains a risky one-off experiment.
And we saw a very concrete example of this industrialization, right, with Principal Financial Group and AWS. They apparently sped up their development of conversational bots using Amazon Lex V2 by automating the entire lifecycle, building, testing, deployment, the whole thing.
Yeah.
Now, automating deployment, that sounds a bit like standard DevOps, maybe. Why is automating the bot lifecycle specifically such a big deal for AI?
It's a massive deal because it fundamentally changes the whole return on investment calculation for AI projects. Previously, many AI initiatives were treated like these expensive, bespoke science experiments. Hard to budget, hard to predict the outcome. By automating the entire pipeline, creating what we could call a scalable, repeatable AI factory, IT departments can start to calculate the ROI of an AI tool, much like they do for, say, new database infrastructure. It becomes predictable, manageable. This shift from one-off projects to industrialized processes is really the only way generative AI moves from being just a cost center to becoming a critical business utility. But we should add a note of caution here, providing some counterbalance. Translating these powerful back-end capabilities into seamless consumer products, that's still proving to be a huge hurdle. There was a pretty critical report on Opera's Neon AI browser, for instance. It noted that even though they integrated various AI-powered widgets, the features just didn't seem to come together into a consistently valuable experience for the user. It seems users don't necessarily want AI just slapped onto every button. We've seen feature bloat kill products before, right? This really underlines the challenge that all the browser vendors are wrestling with right now, how to integrate AI meaningfully, not just superficially.
Yeah, that makes sense. But even with those consumer stumbles, the market is finding specific niches where this works well. We saw some interesting regional products pop up. Like in Frankfurt, StartupRed.io launched something called the Startup AI Concierge. It's a RAG-based knowledge assistant, but it's hyper-focused. It provides traceable, source-cited information specifically for the European DACH region's startup ecosystem. That sounds like a really targeted professional tool built exactly on that foundation of reliability and traceability we talked about.
Precisely. And if we're talking about scale and finding niches, we absolutely have to mention China. The generative AI user base there has reportedly doubled to over 500 million people. It's integrating into everything from daily tasks to massive commercial events like the Double 11 Shopping Festival. That kind of rapid, widespread adoption inevitably plays a huge role in normalizing the technology globally.
Okay, let's zoom out a bit now to the bigger picture, the economic environment surrounding all this. When you see these incredible breakthroughs, like the Gemma cancer therapy discovery, and this industrialization happening at scale, like with Principal Financial Group, but also the struggles with consumer products, it naturally raises a big question about all the money flooding in. Is there an AI financial bubble forming?
The sources definitely confirm this is a complex and pretty polarized debate right now, and it's influencing investor strategy worldwide. One analysis we saw pointed to the sheer scale of investment. Massive numbers, including, get this, $141 billion in debt finance spending just as part of a projected $500 billion total AI spend in 2025. That level of debt injection into a still emerging technology, well, it certainly warrants caution, doesn't it? Regardless of how transformative AI eventually proves to be, it's presented very much as a critical debate point. The financial scale is just undeniable, and it's shaping where capital is flowing.
And those huge economic pressures, they translate almost immediately to the workforce, right? We saw news reflecting two really powerful, almost opposing sides of AI's impact on jobs just today.
That's right. On the one hand, you have the negative impacts. Research, particularly noted in Canada, indicated that AI poses a real threat to entry-level job opportunities for young people. That raises serious concerns about future career paths. And then you see major corporations like Accenture and Lufthansa openly citing AI adoption as a reason for workforce reductions, signaling that the efficiency gains they're achieving are translating directly into staff cuts in some areas. Though we should maintain balance here and note the critique that sometimes AI might be used as a convenient scapegoat for layoffs that are actually rooted in broader market corrections or other business factors.
Okay, but then you have this almost shocking data point from inside one of the frontier AI companies themselves. Anthropic CEO revealed that 90% of the code used within their own company is now AI generated. 90%.
How do we square that? The idea that AI is maybe destroying entry-level jobs over here, while the very companies building the AI are already automating 90% of their own core engineering labor over there.
It really highlights the speed gap, I think. The Anthropic figure shows just how incredibly fast the AI builders themselves are moving. They're dogfooding their own tools, integrating them immediately into their most fundamental processes, like coding. In a way, it previews the future of software development for everyone else, probably much sooner than we think. And you contrast that with more traditional enterprises, like maybe Lufthansa, which are off using AI tools more for cost optimization or navigating those market corrections we mentioned. It's this simultaneous rapid acceleration in core tech development and potentially displacement in more traditional roles that creates this really sharp polarizing effect we're seeing play out in the labor market right now.
Okay, one last piece before we wrap up. Let's look at it.
at the foundational infrastructure that's going to enable the next phase of computing. Even while everyone's focused on today's massive GPU needs for current AI, AWS made a pretty interesting pragmatic move. They released documentation and tools to help accelerate quantum machine learning, QML workloads, but using classical GPUs through their SageMaker platform.
Yeah, this is a really crucial infrastructure bridge they're building. It tells us a lot about where the major cloud providers are placing their long-term bets. Look, truly fault-tolerant quantum hardware, that's still some way off in the future. We know that. But developing the algorithms for quantum machine learning, the QML algorithms, that requires incredibly intense classical simulation right now. So think of what AWS is doing here as providing like training wheels for quantum computing. They're making it easier for researchers to distribute and speed up these super computationally heavy simulations using the GPU clusters they already have access to today. It effectively lowers the barrier to entry for QML research and development significantly. It's definitely a long-term play. Seeding the ecosystem, making sure the algorithms and the expertise are ready to go when the quantum hardware finally catches up. #tag outro. So if we try and connect the dots between these three segments, the foundational research, the scientific breakthroughs, the enterprise industrialization, the overall theme today seems overwhelmingly clear, doesn't it? The industry has definitely moved past just talking about speculative potential. The focus now is intensely on delivering dependable impact, scalable impact. Everything from that micro-level control over model outputs right up to macro-level industrial automation and potentially global scientific change.
So wrapping it all up, what does this mean for you listening? Well, these stories that might seem disconnected at first glance, Meta improving video controls, Google's Gemma model helping with cancer pathways, Principal Financial building bot factories, they actually all point to the same thing, the comprehensive, structured way AI is maturing across the board. Across science, product engineering, core business operations, it's happening everywhere.
And the day's news really highlights that key tension we talked about. On one side, you have real concerns about job losses, questions about whether the investment frenzy is sustainable. But at the exact same time, the core infrastructure providers are busy building the necessary computational bridges for a future that might well include quantum capabilities.
Which leaves us with a final thought to mull over. If companies like Principal are already automating the entire deployment pipeline for enterprise AI, and cloud providers like AWS are actively building the foundations for quantum machine learning using today's hardware, how far away are we really from a point where the speed of AI deployment, how fast you can get it out there and iterate, becomes the only true competitive advantage, maybe even more so than the raw capability of the AI model itself? Plenty to think about there. We'll see you next time on The Deep Dive.